Hello everyone. I will give you another quick video recorded on finding CG coefficients. This is important because it will come up for your test one. The idea would be you want to find the CG coefficients associated with the coupling of the spins of the electron and the proton of a hydrogen atom in its ground state. Note that in ground state, proton and electron have no orbital angular momentum. In this case, you identify J1, J2 as half, okay, and the possible J is J1 and 0. We have been repeatedly discussed this in class, okay. Now we use the following to construct the CG, the possible states of this composing system. The idea in general is given by this double sum, okay. I wrote down over here m half m minus half, okay. And where do I get this? Now recall that for each of your J1, J2, for that particle, electron and proton, they have their corresponding M1 and M2. Okay, so for J1 half, the possible M1 is plus minus half. Similarly for J2, so you have M2 equals to plus minus half as well. Then you can use exponent equation 1 to construct the states. Okay, and then use the table of CG. But if you compose this one, you J1 plus J2, this is for the case of composite system. You have half plus half, so you got 1. Then that's why the possible state using the theorem of additions of angular momentum using theorem, then you have 1, 0. Okay, this is very important. You know that you have two types of spin, one singlet and another one is triplet state. Then we do the following. Okay, for this part, this is maintained J1, J2. So you have all half, 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 and all half. Okay, how many states you have? You have 4. This is your singlet state, and this is the triplet. All right. Now look carefully. You have to take the plus minus sign respect to your M. Okay, M1 and also M2. Okay. Now for your singlet state, you have M1 half and then you have M2 minus half. Okay. So the way you write your coefficients, you have the first thing here. This part will be your inner product. Alright. Okay. And then you multiply with the cat of your state. So since your M1 and M2 has all plus minus half, then their combinations is also plus minus half. Okay, so you have the first one is they are all acting on the same inner product of the singlet. Okay, maybe let me do it with a different color. With this part, they connected to this one. Okay, they also connected to this one. Okay, at least you managed to look at the case of 0, 0. Next, you look at the case of the triplets. Okay, for the case of the triplets, then you look at here, it's 1. Okay, so how do you get 1? 1 is always half plus half. So you have the entry of your M1 and M2 must be half. Okay, I forgot to mention earlier, since this is 0, okay, 0, M, the total M is 0, total M, okay, so that's why you have half minus half, if you 0. So this one total equals to 1, and half plus half is equals to 1. Okay, then you adding Let me give you a color, or green color. This is where you add or the inner product respect to 1, 1. The one that is given in this cat is just following the upper front of the bra side, this side. Okay, let's look at 1, 0. Okay, so for 1, 0, 1, 0, you have to expand a little bit more because you have two possible ways to produce 0. One is m1 half, m2 minus half. Another one, if you have m1 minus half, m2 is half. That one produce the additions of this produce this one. Okay. So similarly, you will get that. Okay. Next is for minus 1. So minus 1 is what? Minus 1 is minus half minus half. This gives you minus 1. So you look at this m1, m2, you add them, they produce minus half. And then you follow the cat part for minus half, minus 1. So next what you do is you read the table of the CG coefficients to get the value of the coefficients. Now let's do this together. For the uh, singlet state, okay, 0, 0. So you look at these 0, 0, okay. So you have under 0, 0, you have two coefficients here. This one, so you have half and minus half. Yellow is a very bad color. Let me okay, blue. So look at this part, okay. So you have half and minus half, but its CG coefficient is always square root. But what is the combinations of the multiplications respect to cat? Okay, so you look at half. So half is the combinations of half half, okay, half half, half half, and half minus half. Okay, sorry, you look at this one, half minus half is this part, and then for this part is minus half half. Good. On this one is just maintain J1, J2, J1, J2 doesn't change. Okay. Now let's look at J11. So 1, 1, you look at this table. So you produce only one. Okay. So 1, 1, the coefficients is only one. Then you multiply with, you have half half. That is J1, J2, and you have this one half half. Okay. Now let's look at 1, 0. 1, 0. This horizontal. So you have half half. You have two. You have half plus. Then you look at that side. You have half, half, half minus half, which should be square root. Okay, and then another one you also have half minus half. You have minus, sorry, half plus square root, half half minus half half. Okay, and then 1 minus 1 this side. Okay, you only have one coefficient, and then it's half half minus half minus half. Okay, that's it. Then this will give you the complete finding CG. What is the questions? CG coefficients associated to two electrons and protons compose composite system. Okay, thank you, class. I will give another examples. You were doing it during your Monday class, okay?